In this video, I'd like to look at some angles in standard position. Before we can talk about angles in standard position, it's important to first have a good definition of what an angle is. And we're going to define an angle to be two rays rotated about a common endpoint. Now, many books and many teachers describe an angle as two rays that just share a common endpoint. But it is important to understand that when we're talking about an angle, we're talking about one side being rotated away from the other side. That means that an angle has two sides. Each of the rays are two different sides. The first side is called the initial side. That second side that is being rotated away from that initial side, that would be the terminal side. Now, there are many angles that all look the same, and that's why it's important to include this arc when you're drawing your angles. I could be talking about the exact same two rays rotated about the same common endpoint, however, have that terminal side rotated around the other way. Then the angle that I have in blue is an acute angle, however, the same looking angle rotated from the other way is a very large obtuse angle. Two angles that are completely different. Now, for an angle to be in standard position, what we're trying to do is to nail an angle down instead of just floating around in space. Nail it down to the coordinate axes. To do that, what we do is make that common endpoint sit at the origin. Then the initial side is going to be the positive x-axis. Any angle that starts off like this is going to be an angle in standard position. If we rotate that terminal side around, so that ends up here, and maybe we rotate this way, this would be a positive angle. However, if we start with our initial side on the positive x-axis and we rotate our terminal side down first and swing it around in a clockwise direction, that would give us a negative angle. So for angles that are in standard position, if they swing up, it's positive. If it swings down, it's negative. I want to take some time now to practice drawing some angles in standard position. Start off with one that we know a lot about, a 90-degree angle. We're very comfortable with those. If we're going to draw a 90-degree angle in standard position, I'm going to start with the vertex of the angle at the origin and the initial side being the positive x-axis. After that, I'll rotate my terminal side in a positive direction, so it's going to go swing up first and stop when we get to a right angle. Since this makes a right angle, we're swinging the terminal side up, and that's our 90 degrees. If we're going to do a 45-degree angle, again, start with our vertex at the origin and our initial side on the positive x-axis, and we only want to go halfway to that 90 degrees. So if we thought about this blue arc, this portion of it being that 90 degrees, we only want to go halfway up, and that will give us a 45-degree angle right here. For a 30-degree angle, we'll go a third of the way. So instead of going 90 degrees, we'll go about a third of the way, just short of half. And that's our 30-degree angle. A 75-degree angle, we're not getting too terribly specific, but I do understand that my initial side has to be on the positive x-axis. I know that halfway around, that's 45, and all the way up, that's 90. So I'm going to want my terminal side to be a little bit closer to 90, so something like this. When we're drawing these angles, it really is an estimate, but we want to get it in approximately the correct spot. Now, if I'm talking about a 100-degree angle, start with my initial side on the positive x-axis, and I'm going to rotate my angle past this 90 degrees just a little bit. And this will give us what 100 degrees looks like. It's often a good idea to kind of reference one of the axes to help us out. When I want to draw in a 150-degree angle, I'm going to think about a 180-degree angle first. 180 degrees is a straight line. So the 150-degree angle is going to be 30 degrees short of that. So I'll go about a third of the way back to the 90 degrees, making this my 150 degree angle. For 200 degrees, again, our initial side is the positive x-axis. I know that 180 is a straight line, and if I added another 90 to that, this would be 270 degrees. So there's 270, and this one's 180. That means 200 is going to be a little bit closer to the 180 than it is the 270. And there is our 200 degree angle. For our 300 degree angle, start on the initial side. We know that down at the bottom here, we're at 270 degrees. And if I go all the way around the circle, that would be 360 degrees. I want to be at 300, so 60 degrees short of 300 or 30 degrees past 270 puts us right about here. That's where the terminal side is. Now, don't be tempted to always put your arc on the smallest side. We're talking about going 300 degrees. That means swinging that terminal side in a positive direction all the way around to here. When the angles become negative, then we still start our initial side in the same spot. However, the terminal side, instead of being swung upwards, is going to be swung down. We're going to go 90 degrees, but down 90 degrees puts us right here. A negative 45 degree angle is going to start in the same position with our initial side on the positive x-axis, and we're going to swing downwards 45 degrees, so halfway to that 90, making this our negative 45 degree angle. Negative 270 will start at our initial side, going down first. This would be negative 90 degrees. Swinging it all the way across to a straight line would make it negative 180 degrees. And putting another 90 on that makes our negative 270 degrees end up on the positive y-axis. But be careful, we are not talking about this angle. Instead, we're talking about the negative 270 degree angle. The last angle I have here is back to being positive, but it's positive 400 degrees. Its initial side, since we're going to be in standard position, is the same as always, the positive x-axis. And now, as we swing that terminal side around, we go from 90 to 180 to 270. And if we swung it all the way around to complete the circle, now we're at 360 degrees. Now, that doesn't mean that 400 degrees isn't a real angle. It just means that we continue swinging that terminal side around, and we need to bring it up a little bit more, another 40 degrees. That would mean that our arc that we would draw to signal this angle starts at the initial side, swings all the way around, and ends up right there on our terminal side. That's what a 400 degree angle would look like. In these last few, we see that the angles are not written in degrees anymore. Now they're in radians. And we have a slight understanding of radians and what they mean. Earlier, we saw that a complete circle, so if we started with an initial side here and went all the way around, that would make 2 pi radians. And so if I'm only going to half of the circle, that's 1 pi radian. So to try and figure out where a third, or pi over 3 radians is, we take that pi radians and divide it into thirds. So thinking about the entire arc over to 180 degrees, or pi radians, we divide it into thirds. I only want one of those thirds, making this pi over 3 radians. If I wanted 2 pi over 3, again, start with our initial side on the positive x-axis and think about this as being pi radians. So divide that arc into thirds, 1/3, 2/3. I want 2 of those thirds, making this 2 pi over 3 radians. For pi over 4, again, we'd start with our initial side. If this is pi, this would be pi over 2, halfway there. So to get to pi over 4, that's half of a half. Cutting that arc in half gives us this as our pi over 4 radians. Initially, everybody struggles with radians and drawing them and visualizing them and understanding them. But the truth is that the more that you use them, you'll see how much more helpful they are in drawing your angles and in doing trigonometry. Earlier, I had said that we could have two completely different angles that look exactly the same. In terms of angles in standard position, that would mean that their terminal sides would lie in the same spot, hence the term coterminal angles. Show you what I mean with 130 degrees. 130 degrees has an initial side of positive x-axis, and its terminal side is going to swing another 40 degrees after 90. So this would be 130 degrees. Now, one angle that would be coterminal to 130 degrees would happen if I were to take this terminal side and swing it around the circle one more time. That would put its terminal side again in that same spot. However, the angle measure isn't the same. What we did is we started with the 130 degrees and swung it around the circle one more time, so we added another trip around the circle, another 360 degrees, making the total angle measure 490 degrees. So 490 would be an angle that is coterminal to 130. Now, similarly, I could also take this terminal side and back it up an entire trip around the circle, making our angle this. So, in essence, what we did is start with that 130 degrees and go the other way. So instead of adding another trip around the circle, we subtract one trip around the circle, making the negative angle negative 230 degrees. If we're talking about angles that are measured in radians, again, we can draw this angle in standard position. 7 pi over 6 would have an initial side as a positive x-axis. Pi, the straight line, that's really 6 pi over 6. So I would need another sixth of a pi to get out here to 7 pi over 6. Now, if I wanted to find a positive coterminal angle to 7 pi over 6, I would just continue to swing this terminal side all the way around the circle one more time. So again, starting with 7 pi over 6, I need to add an entire trip around the circle. But in radians, that's not 360 degrees, it's 2 pi radians. So I'll have to add 2 pi to 7 pi over 6. So I'll get some common denominators here, making that 7 pi plus 12 pi over 6, or 19 pi over 6. And if we wanted to find a negative coterminal angle, I would just take that terminal side and swing it around back the other way. So starting with 7 pi over 6, I would subtract a trip around the circle, 2 pi, which is 7 pi minus the 12 pi over 6, or negative 5 pi over 6.